Structured query language is a standard database language which is used to create, maintain, and retrieve the relational database. Following are some interesting facts about SQL. SQL is case sensitive. No, SQL is case insensitive, but it is recommended practice to use keywords like select, update, create, etc. in capital letters and use user defined things like table name, column name, etc. in small letters. Okay? We can write comments in SQL using double hyphen at the beginning of any line. Then SQL is the programming language for relational databases like MySQL, Oracle, SQL Server, etc. Other non-relational databases like MongoDB, DynamoDB, etc. do not use SQL. Now, we just saw a word named relational database. So, what is a relational database? Relational database means the data is stored as well as retrieved in the form of relations. What do you mean by relations? These are tables. Okay, like the data is stored in various tables and those tables are linked to each other by some relation. Like there may be a key column in it which is used to extract data from some other table in that way. Okay, now the queries to deal with relational databases can be categorized as data definition language. It is used to define the structure of the database. Example, create table, add a column, drop column, and so on. Data manipulation language. It is used to manipulate data in the relations. Example, insert, delete, update, and so on. Data query language. It is used to extract the data from the relations. Example, select. So, first we consider data query language, a generic query to retrieve from a relational databases. Can be like select some column names from the table name. Okay?
So, hello friends. Now, let us get used to some basic SQL syntaxes. If you see here, we have some tables like marks, demo, student course table, and student underscore dataset. Out of this, let us try and explore the content in table marks. If you want to read the data in any table, the syntax that we have is select space. Let us say we want to see all the data in that particular table. We will use star from the table name. The table name here is marks. Once we have this, we will run the query and this is the content in that particular table. If you look here, it has a column student which contains the names of students like A, B, D, E, course, the course they are enrolled in, which are like course C1, C2, C3, and the scores that they have obtained in those particular courses. Okay. Now, this is something that showed us what is the overall table, how it looks like. Let us say we want only two selected columns from this particular table. How will we get it? To get it, instead of this star, we will put the column names. Like, let us say we want only the names of students. Okay. Then select student from the table. This will give us the student names. Now, now let us say we want student as well as course. It will give a student course from table marks. If you observe here, when I selected only students, let us say this one. What did it show us? Student, who are the students? A, B, D, E. If we observe here, we have four distinct students and A is repeated twice. Correct? So this is not the list which we want as a programmer. Suppose if we want the set of distinct students who have enrolled in this course, then to get it, we have another function called distinct. Let us say I want the distinct set of students who have enrolled in the courses. So what I can do is that select distinct student from marks. Let us see what does it give us. See, now here we have A only once, A, B, D, E. This is the intended result. Now, if we want to know the distinct set of students who have enrolled in distinct set of courses, then we will just do a comma here, student, comma, course. And once we run it, we have it here. AC1, AC2. That is the reason we had A twice. But now, when we get or when we select two columns, student and course, the distinct here is AC1 and AC2 as a combination. Hence, A doesn't get eliminated when it had come twice. Okay, so it is A C1, A C2, and other as it is B C3, D C1, and E C2. Now let us say we want to filter out the students who have got or who have scored marks more than, let us say, 50. How will we do it? To do that, what we will do is the basic syntax: select star, that is, we will select all columns from our table, which is marks, where which column are we looking for now to filter out? It will be score, where column score is greater than 50. Let us say what does it give us? See, we have B, D, E. We have scored 60, 70, and 80 respectively in C3, C1, C2. Let us see our entire table once. I'm just copying this command here. And to separate two SQL queries, we will use a semicolon. Okay. Now run. See, A in C1 and A in C2 got filtered out when we filtered for score greater than 50. Now let us say we filter for score less than or equal to 50. Okay. And to run this, I'll select this one and press the run command. See, we have these two. Are we clear till here? Okay. Now moving forward. Now let us say I want to filter for students who have scored more than 50. Okay. But one sec, I'll show you this first. Now for students who have scored more than 50, but in course C1. Okay. Or let us say we want the students who have scored more than 50 in course C2. So here we will need two conditions, right? For that, what we will do is that this one we will use as it is. Just give me a second. Here we will use the AND operator. How we will use it? For this particular condition, let us say I'll take it here for your convenience. Just Forget the part above this. Okay. So select star from marks where score we wanted it as greater than or equal to 50, and at the same time we want that course equals to C2. Let us see what does it give us. Who are those students? It says no such column equal to C2. So let us put this in quotes. Now this is the result that we get. Like student A and E who have enrolled in course C2 have scored more than or equal to 50. Clear till here? Similarly, we can use and multiple times on multiple conditions that you wish for. Now, let us use some other operator. Again, let us go back to our entire table. Now, what can we do is let us say we want to filter out or we want to filter the students who scored more than 50 or students who scored more than 60 in C1 or more than 50 in C2. Are you getting it? We want students who scored greater than 50 in C2 and greater than 60 in C1. Or not and. Now we are going to try for or operator and more than 60 in C1. Okay. So to do that, the first condition will remain as it is. Okay. And this condition will be ORed in this way. And here score should be greater than or equal to 60, or we have taken greater than, so let us keep it greater than, and course equals to C1. Let us see what does this give us. No such column, course. Okay, I missed the S here. Now see, this is how OR operator works. It will give the result either when this is true, like first condition is true, or the second condition is true, or either when both are true. It won't give the result only when both are false. Okay. So the first result, that is score greater than or equal to 50 and course equal to C2. We have two entries for it. C2 50 and C2 80. And for the second condition, where course greater than 60 and score greater than 60 and course equal to C1, we have only one result, which is the student D getting 70 in course C1. Clear till here? Now, let us say we want the negation of this result, like the students who have scored less than 50 in course C2 or student who have scored less than or equal to 60 in course C1. For that, we will use the not operator. And now let us see what the result we get. See, we have C1 scoring 40, C3 scoring 60, C1 scoring 70. Now C1 will score greater than 60 and goes equal to C1, C1 40. Now, when using the not operator, what we will do is that we will put this entire thing in the bracket and then let us see what we get. Okay, this is the part which we wish to run, and now we have got the correct result. C1 40, C3 60. Okay, these two rows and the remaining six. So these two rows and the remaining three, these. Okay, we had got like C1 40 and C3 60. So we have learned how to use the AND operator, how to use OR operator, and NOT. Okay, AND will work when both the conditions are true. OR will work when either of the condition is true or when both the conditions are true. And NOT will work as a negation. Okay, now we are done with this. Now moving forward, let us see. Sorry, let us say the result that we have here contains A, B, D, D, E, and the marks are like 40, 60, 60, 70, 80. But if we want this result in the descending order, currently score is in the ascending order, right? If you want it in the descending order, what we can do is that we can sort this table by the column score in descending order. So how will we do it? The simple process or the simple syntax for it is we will select this table. Now ignore above this. Now select all the columns from marks and order by score. Let us say I don't put anything after order by score. Let us see what we get. It gives the result as it is. Okay. So if we do only order by score or order by any column, by default it takes it as ascending. Okay. Now, if you want to arrange it in the descending order, what we can do is that we put here descending. And now when we run this is what we get. 80, 70, 60, 50, 40, and accordingly other columns got changed. Okay, here. Now, once we are done with the order by, now let us say we want to insert few rows in our given table marks. For that, we specify both the column names and the values to be inserted. And the syntax that we use is like insert into table name and then the values. Okay. So let us say we want to insert into this table. So how will we insert it? Here, what I am doing is insert into marks. Marks is the table name that we want to insert in. These are the column names in which we want to insert, like student, course, score. And the values that we are inserting are these. Okay. B1 in student, C1. Okay, one sec, for your reference, I'll just get this below. So, in student, we will be inserting B and D. Corresponding course, we are inserting as C1. And for D, we don't know the course. So we are keeping it as blank. In score, for B, we don't know the marks in for course C1. Okay, maybe he or she has not given the test. So it is a blank. and D has scored 50 in the unknown course. Let us try inserting this in the table that we have. Okay, now we have run this query. Let us see if it is inserted. So to check it again, we will just select star from marks. And once we do this, this is the result that we have. See, the first 5 rows till 80, we already had them. Now we just inserted B, C1, which doesn't have any score, and student D, who has scored 50, but we don't know in which course he has scored those particular marks. Okay, this is how we will insert values in a table. Now, once we have inserted these values, let us see what are the nulls that we get. A field with null value is a field with no value, correct? If a field in a table is optional, it is possible to insert a new record or update a record without adding a value to this. Then the field will be saved with a null value. But note here that a null value is different from a zero value or a field that contains spaces. A field with a null value is one that has been left blank during record creation. Like we inserted two records here, but these two values, like where did it go? The course name here and the score here. These are the null, or we can say blank values. Okay. Now how to test for null values? It is not possible to test for null values with comparison operators such as equal to, less than, or greater than. Okay. So we will have to use the is null and is non-null and is not null operator instead of those comparison operators. So the syntax to check we will get to know with an example. Let us say we want to check null in course column. So what we can do is that select star from, again the table as it is, from marks, where column student, student, is null. So we are checking if the column student is null, and this should give us an empty table, correct? Because we knew that student doesn't have any null values. Now let us check in the course column. COURSC. And now when we are checking in the course column, again it gives us an empty data frame. But we knew that there are some null values here. So to check that whether those are null values or those are just the blank values, what we can do is where course is null or course equals to blank. Now let us see what we get, and see here we have the result. So what we can conclude is that this blank value which we had inserted, it has not been taken as a null value but a blank value. Okay. Now similarly, if you want to check, or if you want the data from entire table in which course column is not null, to get it, what we can do is that we will do select star from marks, where course is, instead of null we will do not null. Okay. And where did it go? Course, instead of equal to we will do not equal to. Let us see what we get. Hmm. Here, this one gives the entire data frame, but we wanted the data where D column should not have come, correct? So let us see what we are missing here. Now, first thing is that we know that the course column doesn't have a null value. So we can ignore this part. Oh, again, I have something to tell you. Let us say now where course is not null. Okay. So when this is equal to 1, this will always be equal to 1 because it doesn't have a null value. Correct? And then we are using the OR operator where course is not equal to blank value. And this will give result where either of them is true. So in this table, the first condition is always true. And that is the reason it is giving the entire table. So here instead of OR, if we use AND, let us see the magic now. I'm doing these mistakes purposefully so that when you do it, you should understand why the result that you are getting is not what you wish for. Okay? We will learn from our mistakes in this way. See, we have eliminated the row which contained C1 as blank. Sorry, which contained course as blank after changing OR to AND. Now, again, I have this column, sorry, this row BC1 where score is null. I guess that should work because if a particular student has not given an exam, that can be blank. Okay. Now let us see how to use the delete statement. Because if we are not aware that student D2 has got marks 50, but in which course he has got it, there is no point in having that particular record in our data frame or in our table. So what we will do is that we will delete this particular row. Okay. So how to get rid of this row? We can use the delete statement. How does delete work? Is that see, we will delete from marks. Now what do we want to delete from marks? Where we want the entire row. Okay, the condition for entire row. So where student equals to D and, or instead of this everything, we just want to delete all the blank records which are in column course. Okay, so instead of, let us say we had 10 to 20 students where the course was blank. So instead of giving those 20 records one by one in the where statement, we can directly say where course equal to blank. This will save our time and energy. So let us give where course OU where course equals to blank. And once we run this, let us see the result now. See, that particular record has got deleted. Okay, so we have learned how to select the columns, then how to select distinct columns, sorry, distinct element in those columns, then how to use where statement, then and or not operators, how to use order by, how to insert records in a table, how to check for null values, how to update a table, and how to delete a table. Delete few records in the table. Okay. Now moving forward, the blank value that we have in the last row, doesn't look good because the scores cannot be blank. If a person has not given an exam, it can be zero. Why should it be blank? So let us try replacing it. That we will replace blank with zero. Okay. So what we will do, that we will update table marks, set which column course equals to 0. Sorry, not column course. Score equals to 0 to 0. Where? Where do you want score as 0? Where score equals to blank. Okay. Now we will run this. And once we run this, now let us see the result. Whether the table has got updated or not. So we will select star from marks and let us see what does it show us. See, C1 has got replaced with 0. Okay. Now we are done till here. Now, if you want to select the first few records in a given table, okay, how will we select it? Like, let us say table has around 1000 records and you want only the first 10 or first 15 records. To get it, we will simply do select star from marks and we have one, yes, one. Select top, or we can use limit clause to select limited number of records. Okay, limit we can do, we have only 6, we have 6 records here. And if you want only the first 2 records, we can say limit 2 and let us see what it gives us. It gives us only the first 2 sorry, it gives us only the first 2 records. Okay, let us say you want the first 2 records by doing order by square, order by scores, like the highest 2 scores. So what we can do is that select star from marks, order by score in descending order. Okay, and then limit 2. And now let us see what does it give us. See, now we have only first 2 records containing scores as 80 and 70. Clear? Okay. Now we will learn about some aggregation statements, functions, like the mean and max functions. The mean functions returns the smallest value of the selected column, and the max function returns the largest value of the selected column. For example, let us see how we do it. Sorry. Now, select. We want the minimum, all the scores that the students have got. So select minimum score from marks. Let us see what it gives us. So minimum score is 0. You remember we had replaced blank with 0. Okay. Now we want the maximum score. Then what can we do? We will use the same syntax. Just we will replace minimum with maximum. Okay. And if we run, we have maximum score as 80. Now, some of you will tell me that instead of getting this separately, I want this in a single table, like in one row or in one column, the minimum score, in the other column, I want the maximum score. Yes, we can get it. What we can do is that we can replace this maximum score here by giving a comma and remove this. Now it is none of our business. Okay, now selecting these two things. If we run, it gives minimum score as 0, maximum score as 80. Okay, now the titles that we are getting here as minimum score and maximum score, I want to rename those. So I want minimum score as min and maximum score as max. So this is the result that we get. Minimum as 0, maximum as 8. Okay. Now let us see how to use the count, average, and sum functions. Okay. The count function returns the number of rows that matches a specified criterion. Okay. Specified criterion, like if we count directly the number of rows in a table, it will give the number of rows in a table. If we count the distinct values in a table, it will give the count of distinct values in a table. In that way, whatever the condition that we use. For example, let us say we select count. I'll do count star for the entire table from marks. We know it should give us 6. So we have 6 values. Now, once we have these values, I want to see the number of students. Okay, listen again. I want to see the number of students who have enrolled in my courses. How will I look it? Let us say I do like select count student. Okay, count student from marks. It still gives me 6, but I know that there are only 5 distinct students. Sorry, there are only 4 distinct students. A is repeated twice, and I guess D or E in the end is repeated twice. I'll show you the data frame once again. Sorry, the table once again. That you get an idea of what I'm trying to say. See, here the distinct students that we have is A, B, D, and E. So we have only 4 distinct students. But when I run this, it shows me six students. How is it possible? It is counting the number of rows in the column student. So if I want the list of distinct students, I will put a distinct here. I'll tell you one more method to do it, but for now, stick to this. See, we have 4 distinct students. Clear? The second method to get this count would have been select count star from. Now in from, we will do again select distinct students from marks. So here we will have distinct students, and then we will take the count of that particular table. So this should ideally give us 4. No such column students. Okay, it is student. See, again we have 4. Okay, to distinguish it again, I'll give here as method 2. See, okay, clear till here? Good. Now, let us say we want the average of marks that all the students have scored. How will I get it? We have the average function. Average function returns the average value of a numeric column. The numeric column that we have here is score. Okay, so let us say we do select average. Average of which column? We want score column from where? From marks. How do we get the result as 50? Okay, now again let us go back to looking at the data frame, and we'll try to count the records and check if this particular answer is correct. Okay, to check this answer, let's wait for a minute. First, let us see how to get the sum of these records. We won't do it what we say manually. So to get the sum, we have a function called sum, which returns the total sum of a numeric column. So again, the numeric column here is score. So we will select sum of score from where? Marks. And I'll select this and run. So it gives me 300. Now we know that the average is sum of total values divided by total number of values. So sum of total score is 300 divided by total number of values in the score column. How many values we had? 6 values. Like we had six different rows, right? So 300 divided by 6 gives us 50, which was the average score here. But now I know that one of the student has not given the exam. And that is the reason the average score of the students is getting decreased. And hence, I don't want to consider the student who didn't give that particular exam. How will I filter for it so that my average gets corrected? What we can do is that we can take the average by filtering out that particular student or those particular students whose score is equal to 0. Correct? That should work, right? So what we can do is here itself select average score from marks where score I'll say greater than 0. Okay, so 0 will automatically get filtered out. Let us see what we get now. The average goes to 60. So now 300 is getting divided by 5 instead of 6. Clear till here? Good. Now let us try and understand the like operator in SQL. The like operator is used in a where clause to search for a specified pattern in a column. There are two wildcards often used in conjugation with the like operator. The percentage sign represents 0, 1 or multiple characters, and the underscore sign represents one single character. The percentage sign and the underscore sign can also be used in combinations. You can also combine any number of conditions using AND or operators. Okay, we can take one example here. Let us say, okay, before taking an example, again we will go back to our data, select star from marks. See, let us say we want to filter for the course. Here we don't have many options. For that, what we can do, we have another data set called student course table. Let us see what we have in it. Select star from student course table. Once we run this, Okay, again we don't have some fruitful thing here. So student st to be select star from student table. If we do select star from student table, we have this data. Okay. Again, let us ignore this. We'll go to student underscore dataset. Let us see what we have here. Okay, this is the one which will work for us. Now, let us say we want to filter for the names of the students starting with RA. Okay, to do that, what we can do is select star from student dataset where what I had told you earlier that we can use like operator with where clause to search for a specified pattern, and the pattern here is RA in the start of the words in the name column. So what we can do is that where let just give me a second. Where name like now in quotes R A. Okay, name should start with RA and then it can be anything after RA. So we will use a percentage sign. Let us see what it gives us. Okay, it gives us these two value records. Now, if you want to check whether this like operator is it case sensitive, because we have given RA as capital. Let us say we give small r, small a, and then we run it, still it gives the same result. So we can conclude that even the like operator, like SQL operator, is case insensitive. Okay. Similarly, we can filter for many other conditions if you want to check for anything in between. Instead of starting with RA, we can check like where RA comes in between the words or in the ending or anything. Any combinations you can try it. Okay. If we are checking in between, here the syntax will change like percentage. Where did it go? Percentage, RA percentage, which will give us this result. Now, if I want to check if any word is ending with RA, this is the syntax that I'll use. And when I use this, I get nothing because there is no such word. If you see the data set again, we have no such word which ends with RA. Okay. So clear with the like operator. Now we will begin with the in operator in SQL. The in operator allows you to specify multiple values in a where clause. The in operator is a shorthand for multiple or conditions. Okay, like earlier we used multiple conditions, no, or X or B or Z or X, Y, Z, so many or conditions. Instead of that, what we can do is that where column name or where column score in 40, 41, 42, 43. Let us say I want these four values or five values in that way. Let us see how to do that. We are done with this data set. So I'll put it down. Now again, back to marks. So select, I'll do star from marks. Now where, which column? Let us say column score. Column score in 40, 50, 60. And once I run this, I have these three values. And luckily we had these three values 40, 50, 60. Let us say I give here 100 instead of 60. it gives only two values for 40 and 50 because we don't have any value for 100, as we had seen that the maximum score that we have is 80. Okay, so this is how the in operator works. We can use it for the string columns as well, not necessary for the numerical columns. Okay, for example, where column score or where column, let us say, student, in, let us say we want to filter only for A, but A is a string, so A, and we want B as well, so A and B. If we do run, we have the values for A and B. If you notice carefully, this in operator reduces most of our work. Like where student in, we can put as many values as we can. Else, what we needed to write is that where student equals to A, or student equals to B, or student A equal to C. Instead of that, directly we can write where student in X, comma Y, comma Z, comma T, whatever it will be. Clear? Now, let us get familiar with the between operator. The between operator selects values within a given range. The value can be a number, text, or dates. The between operator is inclusive, that is, between and end values are included. Please note this, whenever we use the between operator, it will include the both the endpoints, like from where we are using between. Like if we say the score between 40 to 60, so it will include 40 as well as 60. It is not that it will start from 41 and end on 59. No. For example, where student, see, same syntax from select, what we say, line number 56. Select star from marks, where student, instead of student we will have score, square between. Now this is not required, with score between 40 and 60. If we run this, oh, let me select this and then run. Huh. See, we have these three values, 40, 50, 60. Students are A and B, and courses are C1, C2, C3. Again, I am telling it includes both 40 and 60. Okay. Now, let us say the columns that we have, like student, course, score, instead of score, I want it as scores. I want to rename that particular column. How will we rename it? Or when I select that particular column, I want to rename and select. We have done this earlier, but I'm showing you again. Like, see, select student. This will be as it is. Course, I want as it is, comma, score. Score, I want it as course with same S as capital. And now when I run the same syntax, it gives here scores. Okay. We had done this earlier when we did average, or I guess max mean time. I had shown you how to rename those. So we are done with this as well. Now moving forward, let us try and understand the group by statement. The group by statement groups rows that have the same values into summary rows. Like find the number of, or find the total score by a student in each course, or overall score of a student. Okay. The group by statement is often used with aggregate functions like count, max, mean, sum, average, and so on to group the results set by one or more columns. Now to understand this, again, let us say we want to get the total marks or total score by A. How will we get? Or total score by each student. Here we have A and B repeated twice, correct? So we can do a group by. So select student. We can do sum of scores from mark and group by. Group by will be by student. Let us see what we have. See, A has scored overall 90 marks, 50 in one subject, 40 in other. B has scored 60, D has scored 70, and E has scored 80. Okay, in all the courses that they have enrolled in. Now, one thing to note here is that if we see A shows so many marks, but it can be like A has given two exams and D has given only a single exam, or E has given only a single exam, and the total mass or the sum of mass for A shows more. So to get a holistic idea, what we can do is that we can take average. Okay, and to get it we can do it here itself instead of writing a new query like average of score. Now once we do average, see, A has 90 marks in total but average is 45. B has 16 total but average is 30, and the reason being we know B has not given one exam, that is 0. Now D has 70 marks in total and 70 as average because D has given only one exam. At the same time, E. So now we are getting some holistic picture that okay, A is not the best performer, but A has given more number of exams. That is the reason it shows more score. Okay, but why does B have this less score? This gives a wrong picture for B, right? Because B has not given one more exam which shows as 0 mark to him. So let us try and remove that. And here I am introducing you with one concept. Just pay attention here. I will use a where here, okay? Where column score not equals to blank. See here properly, okay? It gives an error. Why? We can't use a where clause with a group by clause, okay? Because we have some other function called having, which we can use with a group by clause. See, and once what did having score not equal? Oh, sorry, we had replaced it with 0, right? Now the score not equals to 0. Oh my god. Now what is getting happened is that when I am using having score not equal to 0 here, it is first grouping by getting the result and then it is filtering for this thing. And hence to get away with this, what I can do is that instead of filtering it here, I'll filter the marks or the score before doing group by. How is that here? I know I can't use where in group by, but I can use it before it. Okay, so where score, I'll say greater than 0 and then group by student and then take the average. So now we have B as 60. Oh shit, huh? So we have B as 60. Let us try some other aggregation statements like the maximum, minimum marks or the count of exams or the count of courses these people have enrolled in. Okay. Once we get the count, you know how to use max and min as we have used earlier. The same way it will be used here. Okay. So count, we can do courses. And now when we run this, it gives like A has enrolled in 2 courses and this is the average score for him. And BDE have enrolled in a single course, and these are the scores that they have achieved. Clear till here? So we have done with where, group by, those aggregation statements, when to use where, like we can't use where with group by, we have to use it before it. And if we want to filter after group by, we need to use having. Okay, like one sec, I'll give you an example. I have not given you an example here, right, for having. So having, let us say average. We want average greater than 50. Okay, having average, having this average score greater than 50. And now once we run this, the column A gets eliminated because the average for A was 45. Okay, but if I try using where here, I'm showing it again and again so that you understand it. Okay, it gives an error, like we can't use where with group by. Clear till here? To create a table, we have a simple syntax, like create a table, give column names and the data types. Okay, for example, let us say we want to create a table called test1. Create table, I'll open the bracket, create table, then the table name test1. What should it contain? Like column, column, I'll give it as column 1, which will be an integer. Column 2, which will be a string. And that's all for now. And let us try creating it. So we see that column test1 is created here, which contains, sorry, table test1 is created here, which contains columns at column 1, column 2. Now, if you want to insert values in this table, we have seen how to insert values in a table. What we'll do is that insert into, I'll just copy our previous syntax so that we can do it as quicker as possible. This is what we had done it earlier. So now insert into test1, T is small. The column names are call1, call2, and values in it, what we can give it as, let us say we give here capital A, in column B we give capital B, and here we give it as 100, and in column 2 we give it as 50. Okay. I guess this should be it. Once we run this, it says incomplete input. Let's remove this out and then run it. It has inserted. Now, let us say we want to look the table that we have created. We can do select star from test1. Let us select this, and when we run, we have column 1 containing values A, B, and column 2 containing values 150. This is how we can create a table. Now, let us say we have created a table, but we want to drop some tables. Okay, the table is no longer required and we want to delete it. How will we drop the table? We have a simple command called drop table and the table name. So let us say we want to drop table test1. Simply we can do drop table test1, select this and run it. See here the table has got deleted. Again, if we try running this select star from test1, it gives an error saying no such table because we have already deleted that or dropped that table. Okay, now let us move to the other steps. For example, the joins, because that is the most critical thing. A join clause is used to combine rows from two or more tables, okay, based on a relation or based on a related column between them. Let us say we have a common column between two tables or two data frames, which acts as a key column to extract values from the other table. Then we will join on that particular table and extract those values. Okay. For example, let us say we have these two tables, student course table and student table. Let us see the values that we have in them. See, student course table contains course ID and enroll number. Like course ID is 1, 2, 3, and 1. And enroll number are these 1001 and 1002. At the same time, student table contains information of the student name, their address, and the enroll number. Okay. Now, let us say someone has given you one of these tables, like the table 1 or table 2. Let us say you have this table, enroll number, student name, and address. And now you want this column, course ID, because you have here enroll number, but you don't know in which course has this student S1 enrolled in. Okay, because see, you are aware that student S1 or S2 or S3 have enrolled in one of your courses, but you are unaware of the course that they have enrolled in. To get that information, if we say S1 here corresponds to 1001 and 1001 in this particular table corresponds to course ID 1. So can I say that student S1 has enrolled in course which belongs to course ID 1? Correct? Similarly for others. But we can't do these things one by one. Correct? So to get this information at a time on the entire table, we will use the join operations. So we have different kinds of joins. We have like inner join, left join, right join, full join, and so on. So let us look what an inner join is. The inner join keyword selects records that have matching values in both tables. Okay. For example, let us say the enrollment number. Enroll number in our student course table is 101, 1, 1, and 2. So we have only two distinct values like 1001 and 1002. But in our student table, we have data containing enrollment number as 01, 02, 03, and 04. So we have two extra values. If we do an inner join on enroll number, it won't consider 1003 and 1004 because the only common values in both the tables are 1001 and 1002. Okay, that is what an inner join gives us. Basically, it gives us the intersection of two tables on that particular key column. Let us try doing the inner join on these two tables so that we get an idea how the result will look like. Okay, so for now, I'll do select star from now. First table, I'll take this as it is. this join. Now here instead of join, what we will do is that which type of join we want it as inner join. So select star from student course table, which is this table that we are seeing in our screen. We will inner join this table with student table. Once we do inner join, now we will have to specify on which column you want to do the inner join. Okay, so for that what we will do, on it will be like which column from student course table dot enroll number equals to student table, and which table from this particular column, again the enroll number. And once we do this, let us see the result. See, it gives us values only for 1001, 1001, 1001, and 1002. It has eliminated those two values. Which two values? 1003 and 1004. Similarly, this particular inner join could have been done in some, what we say, easy way, instead of writing this entire student course table, student table, while doing the inner join. Here, while select star from student course table, we will have given this as variable a. Okay, and inner join table, student table as variable capital B. Then here, instead of writing this entire thing as student course table, we can write just a dot enroll number and b dot enroll number. Here b represents student table and a represents student course table. And now if we run this, it should give us the same result. Okay, so this is how the inner join works. We can join on multiple columns as well. One more thing. Now, if we observe here, enroll number has got repeated because our first table, student course table, also had enroll number as well as the second table. So there is no point in having these two values twice, correct? Hence, what we can do is while we are selecting the columns, we can give the column names as select course ID, comma, enroll number, comma, student name, only the required columns, okay? And the address. And now if we run this, ambiguous column, enroll number. Again, now here it is asking that this particular column, enroll number, it is ambiguous. Why? Can you tell me? Because enroll number is in table 1, that is table A, student course table, as well as table B, which is student table. And hence it is confused. Like from where should I pick up this table? And we know that as this is the key column, we can pick it from anywhere, either A or B. Okay, so here we can give it as A dot enroll number. And now if we run this, this is the result that we have. Clear? Great. Now let us move towards the left join. Let us understand what a left join keyword means. The left join keyword returns all records from left table and the matching records from the right table. The result is 0. The result is 0 records from the right side if there is no match. Okay, so if we do a left join, it will give us the left table as it is. Just the matter is the records from right table will appear only if it has the matching records in key column. Okay, so again I'll give you, or I'll show you this with an example. Oh, okay. I'll run this again. This part. These are our tables. Okay. Student course table, that is table A, and this is table B. We know that 1003 and 1004 are not in table A, correct? So if I take this table as the left table and I left join it with the table A, it should give me all these four records and the records which are common in this table. Okay, let us try so that you understand it. Select, give me a second. For now, we can do select star from this table. I'm taking it as B even now so that it will help us to understand or compare both the results. Here star from table B. Then instead of inner join, I'll do it as left join. Okay, left join with whom? With this table, which we are taking it as A. Now to join again, we have the same key. So I'll copy this as it is from the previous one. And if we run it now, let us see the result that we have. See, if you observe the first four rows, 1001, 001, 001, and 002. These were present in table A, sorry, table B. And hence we have the records as it is. But 1003 and 1004, which were present in A, but were absent in table B, sorry, which were present in B, but were absent in A. There, we have the values as null in the columns which were part of present, which were part of table B. To make it clear, I'll again show you these tables. See, this was our table A, which contained only 1001 and 1002. But this table contains 003 and 004 as well. Okay, so once we join this table with this table, so columns like address, student name will remain as it is, but the extra column that we are getting is course ID, which won't be mapped for this particular column 1003 and 1004. Hence, it will give null values in those columns. Okay, and that is the reason why we are getting here nulls in this particular result. Okay, course ID we are getting it as null, and this enroll number, this particular column we are getting from table A. Hence, here also it is replacing with null. That is the reason when we are selecting the columns, required columns, because this enroll number and enroll number is getting repeated, but we want the enroll number from the table which we are taking it as a left table. Hence, again, we will use the same column names here instead of star, but here instead of a dot enrollment number, it will be B, because B is our left table. And once we do this, this is the result that we get. I guess, okay, this is correct. Just we will replace this one, course ID. We will put it in the end so that it is a bit good for our viewing. This is the result that we are getting if we do a left join. So are we clear with the inner join and left join? If we are clear, the right join is similar to left join. Clear till here? Once our querying part is done, I'll post a small video, graphical video explaining left join, inner join, and outer join. Okay, that should do a thing. Now, moving forward to the full outer join. If you remember what we did in inner join, we just took the intersection of two tables, that the common elements or the common records corresponding to those key columns. In left join, we took the entire left table and the common records in the second table. In full outer join, what we will do? All the records in first and all the records in second. How? We will see it. Just give me a second. Let us say I'll keep this as it is for now. Paste this below. And instead of here left, I'll do outer. And for now, let me keep this as star so that I can explain the differences. Okay. And on outer, let us do it as full outer then. If we do full outer join, again, these are the values that we are getting. But if you observe, we have all the values, like all the enrollment numbers, all the 6 records basically. Before seeing, let us go back here. See, we had 4 records here, which contain 1001 and 1002. And here we have 4 records, 1001 to 1004. But if we get back here, 1001 had come thrice. Okay, and here it is only once. So in full outer, what it is happening is that these records plus the records in first table. Okay, here it has occurred once, 1001, but there it will get repeated 2 times again for course ID 2 and course ID 3 as well. And that is the reason we will get total 6 records. Okay, so let us see the result again. This is the result when we do full outer join. See, 1001 for course ID 1, for course ID 2, for course ID 3, and the other records as it is, like 1002. And we knew that 1003 and 1004 didn't have a enrollment number in the first table, and hence the values have been replaced by null. Okay, in the join. Now again, if we want only the selected columns, like we don't want the enrollment number from the second table, we can skip it by again selecting these required columns. In this way, if we run it, this is the result that we get. Okay, again, to clarify, I'll run the left join thing so that you can differentiate between left join and outer join. See, if we do a left join here, though we are getting 6 records, because 1001 will be made with every row or every, what we say, record of the second, or what we say, of the first table which had enrollment number as 1001. That is the reason we are getting 6 records here. But here this will work as a union, records in first plus the record in second. Okay, I guess the inner join, left join and outer join should be and is clear till here. Now, once we are done with these things, let us see how the union query works. The union operator is used to combine the result or result set of 2 or more select statements. Okay, every select statement within union must have the same number of columns. Take a note of this. Then the columns must have similar data types. Whenever you are doing a union, the column should be same, the data type should be same, and the column in every select statement must also be in the same order. Okay, If you are clear with this, we can try one union statement here as well. Let us say we do select. Hmm, one sec. First, we will see the column names that we have so that it will be easier for us to do. Let us take these two. What I'll do is that I'll select first two rows for once and the entire table in the second one, and then we'll do a union. Okay, so select, I'll do star from the table name, that is our student table. Once we do this, I'll do limit because I want only the first two records. Then union, in union, again I'll do select star from the student table. And once we do this, let us see what is the result that we are getting. Limit clause should be upon the union, not before. Okay, what we can do is select star from here. Select star from. Okay, I'll tell you what I did here is that I selected first two records from student table and I did union. Before doing union, I'll do union all so that you understand the difference between union and union all as well. Okay, what I did is that I selected only first two records from student table and then I union it with the student table. And this is what I'm getting. Like these were the first two records, okay, for S1, S2, and these are the entire records. And once I do union, this is the table that I'm getting. But if you observe, the first record is similar to the third record. See, first row 1001 S1 and City1 is same as 1001 S1 and City1 and similar to second and fourth record. So there is no point in having these duplicates here, right? And union all, what it is doing is that it is not checking for duplicates, it is just unioning the tables that you are giving. But if I do only union instead of union all, let us see what it does. See, it removes the duplicates. It takes only the distinct values that we have given. Okay, so here you got to know how to do union as well as the difference between union and union all. Also, 2 points to be noted here is that the columns that you have selected should be same in the same order and they should have same data type. Clear till here? Okay, thank you. Now let us say we want to create a view. We know how to create a table, but now we want to create a view instead of creating a table. Okay. In SQL, a view is a virtual table based on the result set of a SQL statement. Okay, whatever the result that we are getting, we can create a view of it. A view contains rows and columns, just like a real table. The fields in a view are fields from one or more real tables in the database. You can add SQL statements and functions to a view and present the data as if the data were coming from one single table. Okay, and a view is created with the create view statement. Like the table that we are getting here, let us say I put here union all so that we can differentiate between the two tables. And I can do here like create view and I'll give the view name as test1 because we have already deleted the previous test1 as. So create view test1 as and this particular statement. So here it has created a view. If you see tables are different, a view is different. Now, if I do select star from view, what is the view? Test 1. We can query simply as what we do on a table. This is the table that we have for the view. Okay. So now we know how to create a view as well. I guess this is all that we had in this basic course. Apart from that, I guess you know how to delete a table. Similarly, we can delete a view like in this way. See, draw view and the view name. What is the view name? It is test 1. And once we run this, it should get deleted. See, the view got deleted. Okay. So we are done with our basics of SQL. And these syntaxes will surely help you in whatever queries or whatever task you are doing. Maybe you are testing, maybe you are developing something, you are scripting. These syntaxes will be handy everywhere. Okay. So thank you for being part of this course. I hope you learned something helpful and it was really a good experience.